block diagram then will certainly enable us to understand system performance. It'll you know, and yes, it'll give us an answer. So it'll say, well, based on that system with that, you know, those assets in that configuration, using the reliability block diagram model, you know, we might predict a level of availability. Might be 92% for a particular system, and that may or may not meet our targets. If it doesn't meet our targets, this is really where we get to start to investigate and understand what the key bottlenecks are in terms of that plant now. So we can interrogate the model. This is where the value comes in. We can interrogate the model, understand what the critical bottlenecks are, understand what the important equipment is from an importance perspective in terms of detracting from the performance. And then we can start playing around. We can start assessing different levels of redundancy. So in the previous little RBD, we had 3 pumps, maybe we need 4, maybe we can get rid of 1, save some capital costs there, because from a system assessment perspective, 2 pumps is fine. You know, we can play around with equipment sizing from a capacity perspective. So there's lots of value in having this model and continuing to use it. Again, this is the theme, that we want to connect all these things together, continue to refine and review, rather than have siloed assessments of reliability if we are in fact doing that. So really valuable from an RBD perspective to keep coming back and updating that. And the way I like to think about this is, as we progress through the project, is that we really get to document and store the reliability assumptions. So we can keep pace with all of the changing content that we have. We can start building in detailed plans and maybe even work instructions of how we're going to do things. We can capture everyone's input. We can link off to content and maybe OEM content that's important. So there's a whole lot of value in having this model and using it as a basis for capturing of relevant content as it relates to how we're going to care for the assets and the level of performance that we're going to get from them, which might be material related, might be OEM recommended plans, might be reviews that are conducted, anything that's associated. It really enables us to have this singular point to collect all that content and make sure it's used where it's relevant across the life cycle of the project. And of course, as we build up that content, then that enables us to really start to get towards making really effective decisions from a data perspective and justifying our maintenance strategies. So we in that FAMECA structure leads us down the path, quantifying the impacts of failure, and really important that we understand that from a dollars perspective, and we understand the impact of unavailability or capacity reduction and what sort of cost that is for us. You know, we can document and represent asset and component life expectations using distributions, and a point always comes in every project where people will say, but we don't have the data to represent the life expectations of the assets. And that obviously is true if this asset it's a new project, so it's not yet in operations. But what is also true is that we probably have lots of industry experience related to that asset in these types of industries for several installations. So, and that may even be within the same organisation. Most organisations, when they're building plants, are building a type of plant that they already operate and maintain and have done for years. So they have some level of experience. Even if it's new technology is generally made of existing components that we have access to, you know, motors, gearboxes, pumps, tanks, pipes, valves, etc., etc. So there's generally not much new that we come across, and we can certainly tap into our collective experience. The important aspect here is that we use that experience to actually create representative distributions. It's really important we go beyond that mean time between failure or the averages and get to representative distribution. It can be quite broad, right? We can have quite a bit of variance around it, but we want to move towards a distribution. And that's relatively easy to do once we tap into the right data sources. And then once we've got that in there, we can then go about identifying and assigning quantifying all of the resource and material requirements we need, such that we can then optimize the strategy and determine the best plans for this asset to go into operations. And the important thing here is it's based on data. So as we move into operations, we've set this foundation for continuous improvement.